Thanks for the introduction. Welcome. Today I will talk a bit about patterns we see in normal software design and also look into how OSGi can improve these patterns. Some of them are already there, some might emerge. And so first, as you heard, I've done a lot of open source work. So this way I became a Apache member and I'm a committer in various projects at Apache. Please follow me on Twitter if you like. And also have a website. It's now 2 websites at the moment because I'm transitioning to a new one. So the first one is still the old one, a bit outdated, and below I'm currently preparing the new one. I also have 2 lovely daughters, as you can see. Totally great. So, software design patterns. What are they? So, is it a pattern when you find a cool solution that applies at one point? No. A pattern must be reusable. It must be kind of a template you can use for many situations that are similar. So, there's a typical way of setting up a pattern. You need a context that describes when to use the pattern. You need a description on how to, in detail, to use it. And importantly, of course, all the patterns broadly announce the advantages, but there are also typically disadvantages. So whenever you choose something in software architecture, it's never only this and you're fine forever. It's always a trade-off, and this is very important when looking at patterns too. So, are patterns a golden hammer? For sure they're not. So whenever you can do something in a simple way, without any indirection, any pattern, just do it in a simple way. Patterns are not there to always be used. They're for specific situations, and you should use it for the suitable situations. So always ask yourself, when I look into the context and advantages, disadvantages of a pattern, does it really apply? Don't try to apply just a lot of patterns all over the place. It does not help your architecture. So, what about OSGi? OSGi has some special properties to it, and what I would like to look into is how these special properties might influence the patterns you use. So you end up with a different pattern that does a similar job as an original pattern, but maybe does it better in the context of OSGi. So in OSGi we have a dynamic runtime. That means bundles, services, packages, they can all go up and down. And so you have to cope with that, but you also have some special services in OSGi that help you manage this in a more automatic way, and sometimes the patterns can use that. There's also strong modularity, so this can help in some ways where in some other architectures you cannot scale to a lot of code. In OSGi you can, and some patterns then make more sense for OSGi than other ways. And you also have typically in a, let's say, a Spring application, you mainly focus on building your application, how it's set up to start working. You seldomly think about shutting it down, and normally when you end your application, you have to shut down in some way, but as you do it seldomly, you do not practice it well. So often the code lacks is exactly at that point. And in OSGi, you do that all the time, so your code is typically well prepared for construction and deconstruction, at least after a few trial and error cycles to make it good. So a typical pattern, maybe one of the most well-known, is the observer or listener pattern. So you have some event source that wants to say, I've changed something, wants to let a part of the world know, and you have listeners that are interested in these changes. So the typical listener pattern means you have some code in the listener that registers with the event source, and then whenever something changes, you get an update with an event object, you get notified. So the good thing already, this one of the reasons why this pattern was introduced, is you're not coupling your event source to your listeners. So without the pattern, maybe you would directly say, inform this and this and this object, and the listener pattern allows you to be decoupled from the event source side. So a listener still does need to know what the event source is, but the event source does not need to know. One other problem with the listener pattern is that you have to manually register with the event source. You should not forget to unregister when you're going down. Often there is sometimes just an add method, so it's not always well suited for dynamics. So in OSGi, a very well-known pattern that follows the same principles as the listener pattern is the OSGi whiteboard, but it goes a bit further and uses some special properties of OSGi. In that case, the special property is the service registry that allows you to query what services are there, but also get notified when things change. And this makes it a lot easier to do this whole registration and unregistration of listeners, and it also allows it to be more decoupled. An event listener in the whiteboard pattern simply says, I'm here, I'm interested in events of a certain kind, normally simply by registering with its listener interface. Several of these event listeners can register this service, and the event source simply can get the services or be notified of their existence. And whenever it needs to send an event, it just sends to all listeners that are currently present. One directly obvious thing is you can have two event sources or several event sources. They can all look into the common set of listeners and all inform the listeners. So the listeners are now also not coupled anymore to the event source. And in addition, you can have many event sources that feed the same listeners. But there are also drawbacks of this approach, because I guess most of you, when you have worked with OSGi, might have used the OSGi HTTP whiteboard. You register your servlet as a listener, and then you start your application, and it doesn't work. It doesn't appear on the web. And you may have forgotten to install the HTTP whiteboard bundle. And nothing in your system tells you that something is wrong. You're seeing just no error and nothing happens. So it's a bit, sometimes this whiteboard pattern is a bit difficult to debug when something goes wrong, because you don't see anything. And so with the new OSGi specs, there is an improvement to the whiteboard patterns by adding these annotations for defining service properties as well as defining requirements. So this allows to have a simple annotation like the HTTP whiteboard servlet pattern, and this annotation publishes your servlet as a service that makes itself aware for the outside to receive, to be picked up by the web server, but it also defines a requirement for having the HTTP whiteboard present. And so when you use this, and you use a resolver to set up your application, it cannot happen that you simply forget the whiteboard server, the HTTP whiteboard server. It will be automatically picked for you, so it cannot happen that this unfortunate situation where nothing works and you see no errors. You will be directly informed at the point where you resolve all your bundles, you build your application, that something is missing, or it automatically maybe even selects the correct bundles for you. But still, the listeners might miss updates, so I've not added a slide for that, but it's also even one more enhancement for the whiteboard, where you can say, if you have an event source that sends updates to several listeners, and a listener comes late, it might have missed some updates, and the good kind of advanced whiteboard implementations then might send them additional updates of the history to keep them up to date. So there's some OSGi services that make use of this idea. Another popular, it's even bigger than a pattern, is a way of making your application, is dependency injection, typically with constructor, field, or setter injections. And in the modern ways, you use annotations to mark what to inject, where to inject. So you don't want to have that in XML anymore. That's already very well solved in the new dependency injection frameworks. But they're all, at least outside OSGi, they're all made for kind of just creation of your system. They are seldomly made to handle dynamics like, for example, you update configurations, you want things to happen like, when I change this configuration, some service should go down, another service should come up, and things should adapt to changes in the environment. And simple dependency injection frameworks do not typically cope with that problem. So you typically need to restart your application to make changes. Yeah, and also such a dependency injection framework has to set up your whole application all at once. So there must be one complete process from down to the bottom of the deepest inner workings of your application up to the top that sets it all up in one go. So Spring typically works like this. While in OSGi, we have these special properties of being dynamic. So in OSGi, the pattern of dependency injection is more reflected with this service injection. So maybe you have some dependency injection inside your bundle even, but the OSGi level is more this injection on the service level between bundles, and there you can fully profit of the dynamic nature of OSGi and have a similar pattern than dependency injection, also working typically now with annotations, and so it looks similar, but it has special properties because of OSGi. So each component, especially in declarative services, which is one of these implementations of dependency injection in OSGi, has its own life cycle. So you can have a component that has several mandatory references, and it will only come up when all of these are present. For example, one service reference, one configuration reference, they are all mandatory. So your component exactly comes up when all of these are present. So you cannot have the thing that your whole bundle cannot start because something is not present, or your component starts too early and then has to deal with something not being there. So it embraces the dynamic nature, but still makes it easy to use. Yeah, another thing is, as OSGi is built on this dynamics, you know everything can go down at any time. You always, if you do it well, you always also think about shutting down your components. For example, if your component opens a database connection, it will close this when it shuts down. So when your system reacts to changes and you do it well, you will clean up nicely and adapt really to the change without leaving a mess behind. And also, because the injection is on a higher level with services instead of all your inner workings, it can also allow to have different dependency injection frameworks to work together. For example, you can have a blueprint and declarative services and even CDI now in the same system, and they can all exchange services with each other and still work together flawlessly. But still, there's one disadvantage still present. OSGi is a lot harder for beginners if you're not used to these dynamics. For example, if you have rippling changes through your system or something comes up first in the wrong way, then it comes up later again to correct itself. You have to deal with these dynamics. Sometimes you cannot avoid to be a little more involved in them. So OSGi can help to improve the dependency injection pattern, but it also has its drawbacks, like any pattern. Another popular pattern, especially in the cloud, is the circuit breaker. it is typically done in a way like this. So you want to talk to some external service. Your consumer wants to talk to that. You typically have a client for that to access the external service. And then the circuit breaker basically works like a fuse in your home. By default, it's closed, so your current is running, so your power is there, you can use some device. But when something goes wrong, the fuse opens and the power is broken to avoid further damage on your systems or on your health. And in the same way, such a circuit breaker allows you to, normally when all is good, work without being much visible. But when something goes wrong, it switches to some kind of fallback mode, so your system doesn't completely break down, but only loses a small part of its functionality. So typically a circuit breaker is done like a proxy. So for the consumer, it looks like the interface of the client you want to use, but it is in between. It works on every call you do, and from timeouts or from errors you return, it determines if it should be closed or open, and when to close. So the good thing in the circuit breaker pattern is it can directly react on timeouts and errors as they appear, but you always have this ugly proxy in between where every call has to go through. It makes debugging harder, and so it's a bit unwieldy to use. It's also something you would not want to implement yourself, because doing such a proxy well is hard work. So you need an external lib to do that. In OSGi, I recently used a kind of simple pattern that doesn't require a proxy, but allows you to have some of the properties of a circuit breaker without having a proxy in between your calls. So the idea is that for the normal usage, you have your consumer that calls your client code, that goes to the external system, returns maybe some results. It's all working in the normal way. Nothing in between. There's no proxy that you need. And the idea of the out-of-band circuit breaker is that you have a checker kind of thread that continuously checks if the external service is still available in some way. Maybe it calls it and checks if there is no error coming back. Maybe it has some other way of checking. And this checker creates and destroys a marker service that just says your external service is there or it's not there anymore. And your client just needs one additional mandatory reference to this interface of the marker service, and automatically a system like declarative services with this individual component lifecycle then takes down your service, your client, which is also a service, when your marker service is not there anymore, and brings it up again when it's there. And this can be easily combined with the service ranking. So you have your main service as a high-ranked service that is preferred, and your fallback service as a lower-ranked service. So by default, the high-ranked service, the real production thing, is used. And if the checker takes down your client, automatically the consumer falls back to your fallback client. So it's a similar effect as the circuit breaker, but it doesn't need a proxy, and you can quite easily create it without a lot of technical detail. You just reuse the ideas of DS with the dynamic nature of your components. The drawback, like in all cases, the patterns have drawbacks. It does not cover all the cases. So if your checker thinks your external service is up, but in fact there is a problem, then your client will still go to the external service and cause your system to have problems. So in many cases you will need a full circuit breaker, but in some cases you might use this simple pattern to have a solution that is less technically involved. So you might have noticed we're going from the very small things to the larger things. And this is the last set of 2 patterns that I want to introduce. It's around microservices and how they relate to domain-driven design, and how maybe current way of doing microservices without OSGi is having a lot of drawbacks, and OSGi might help to make microservices better defined, easier to manage. To do that, I need to explain a bit of domain-driven design. So there we have the concept of entities. An entity has an identity, it can have a life cycle. It's like, for example, an object representing a contract or a customer or something that is kind of representing something in reality. And aggregates are classes that kind of manage those entities, like the repository pattern also. And in front you might have services that allow access to these aggregates. And you could have many of these aggregates in one bigger thing, which is a bounded context. So the special property of a bounded context is that inside you should apply the dry idea, do not repeat yourself, but between bounded contexts you should not. You should not share code between bounded contexts. And now let's see how that applies to microservices, how they are done today, and how I think they could be improved. Typically what we see out there is one microservice per aggregate or per service in that domain-driven design model, which results in a very fine-grained architecture of microservices that, as they live in the same bounded contexts, kind of either they share code or they duplicate code, or they need another service for the duplicate code, which creates another thing to manage, and another dependency, another remote call. So the reason why this is the most widespread approach is that it's easy to start with. Such an aggregate is easy to build at the start. Spring Boot provides you the perfect way to do that. You just have a single module that you build. It's having everything to run, so it's easy to start with. But then when you grow, you see, oh, I need to share this. I create another microservice. I need to share this. And we have all these dependencies. And in the end, you have a big problem because all of these remote calls, and you need to manage their APIs because they might need several versions at the same time. So it's really, it becomes very cumbersome over time when you grow. And yeah, it's typically, instead of having your monolith with a jar hell, you now have REST service with a dependency hell, where the problem is not in the one part, the problem is in the interdependency between the parts. So how can OSGi maybe make this better? So the idea is, try to maybe just go back to the original. So this is how we would have it in the current design. One microservice here, one microservice here, and many interdependencies because they live in the same bounded context in the end. And what we could do is to put all these aggregates that live in the same bounded context together and put them into the same microservice that, of course, then have to offer 2 or many endpoints. But the advantage is that bounded contexts are very near the original idea of microservices, because microservices were not meant to be fine-grained interactions in between. They were meant to have the same ideas as a bounded context, like do not repeat yourself inside the microservice, but do not share code between microservices. And this is exactly where I think the better match is if you make your microservices bigger in the bounded context level. And this is exactly where OSGi can help, because when you make them bigger, then the single module idea of Spring Boot doesn't really match anymore. And if your microservice is bigger, it is very appealing to say, I built still these aggregates that I have inside, but their interdependencies are now not REST service calls, but they are OSGi service calls. So you use OSGi services to do the communication, to do the decoupling inside, and you can share code there. You do not repeat yourself inside. And between these bigger clusters, you do not share code, and you use messaging or REST to communicate, like in the normal ideas of microservices. So the good thing is that this matches very well how microservices were thought of in the start. You have a lot less remoting, which is very cumbersome when you want to debug that. You also do not need to manage the API in all cases, because all communication that is inside the bounded context might even be in a single release unit. So when you do refactoring, you can do it over all the bundles, and you have one change that is in the next release, it's all changed without rippling through your whole system. And you can implement this idea of the system of systems in a much better way. There is the disadvantage that it doesn't work well with Spring Boot, but I think maybe for us it's even a good thing, because I would like this to see these architectures to use more OSGi. So we threw the patterns. We went from a very small, very simple listener pattern up to the biggest microservice design patterns. So any questions? Yeah, the first talk where I'm not going over time.